Okay, hey y'all. We are going to do the quadratic formula and then the method of substitution. So for the quadratic formula, what we do is we are going to identify our A, B, and C parts because I noticed in the formula I needed A, a B, and a C. And the formula is x equals negative b plus or minus the square root of b squared, then minus 4ac all over 2a. So this might not be the funnest method to use for a lot of people, but it is going to be a way that you will always get an answer. Sometimes you can't use factoring. Sometimes you can't do completing the square, but you can always use the quadratic formula. So if I look, what I have is my A is 8, my B is 2, and my C is a negative 1. So what we do is we're just going to plug everything into this formula. So my formula states that x equals negative b, so negative 2, plus or minus the square root of 2 squared, and then a negative 4 times a times c, and this is all over 2 times a. So we have x equals negative 2 plus or minus the square root of 4, and then 4 times 8 is 32. Signs are different, so it's negative. Then negative 32 times a negative 1 would be a positive 32. It's all over 16. And then we have x equals negative 2 plus or minus the square root of 36 over 16. So we have x equals negative 2 plus or minus 6 over 16. Okay, so here you can't necessarily look at it and be like, oh, I can reduce. You don't do that here. If you get to a point where you no longer have a square root, you don't have something underneath the radican that can't be reduced, what you do is this is actually going to be 2 of my solutions. I've got x equals a negative 2 plus 6 over 16, and I have x equals a negative 2 negative 6 over 16. So negative 2 and a positive 6 signs are different, so we would subtract to keep the sign of the larger. Over 16, we would actually get a quarter. And then here, signs are the same. Add and keep, we would actually get a half, and it's negative. So this is saying x equals we have a quarter, and we have a negative half. Okay, so that's the quadratic formula. You won't always get numerical values. You could get something that is like x equals 5 plus or minus the imaginary unit square root of 7 over 12. You could get something that honestly looks a little crazy, but you just need to trust your math whenever you do plug everything into the quadratic formula. Okay, so let's do the fifth method, which is substitution. Here what we do is we replace and we solve. So for our problem, we have y to the fourth power, a negative 2y squared, and a positive 1. So I actually don't really have anything just yet to do whenever my leading variable is raised to the fourth power. Everything that I have is whenever it's being raised to the second power. So what I'm going to do is actually substitute. Instead of y squared, I'm going to let x equal y squared. I notice that that first term is actually being raised to the fourth power. I don't let x equal y to the fourth because that middle term is being raised to the second power. So what I do is I'm going to pick x and I'm going to let it be equal to whatever my variable is with the lowest power. So here it would be y squared. Now, in order to actually substitute my x for that first term, which is y to the fourth, I need to figure out if I have y to the fourth, me write that a little bit better. If I have y to the fourth, how did I get there from x? Well, my x equals y squared. And for me to go to the fourth, what I would do is square my x. The reason why is because if x equals y squared and I square my x, what I'm doing is I'm squaring my y squared. Exponent rule just states power to a power, you multiply your powers. So x squared equals y to the fourth. Okay, so I'm literally going to now substitute x squared, and then I have a negative 2y squared. Well, in my box, I said let x equal y squared, and then positive 1. Okay, I know how to work with this, right? That's a trinomial, and I can do the AC method. And what you would end up getting is my x's in the first spot, and then I know that I need to have two numbers that multiply to give me 1. Fairly easy, right? The only numbers that multiply to give you 1 is 1 times 1. Now, it needs to multiply to give me a positive number, but those two ones need to combine together to give me a negative 2. The only way that's going to happen is if they're both negative, because a negative 1 times a negative 1 gives me a positive 1. A negative 1 plus a negative 1 gives me a negative 2. Now that I've factored it, I can replace back into, and what I would get is my x equals y squared, right? Y squared minus 1, y squared minus 1. That is how you would solve a problem if for any reason you don't have squared as your variable. Okay, that is it, y'all. Let me know if you have any questions, okay? Thanks. Bye.